In the summer of 1054, astronomers in China looked up at the sky and saw something impossible. A new star had appeared where no star existed before, and it was so bright they could see it at noon with the sun directly overhead. For 23 days, this ghost star hung in the daylight sky. At night, people could read scrolls by its glow alone. What they were witnessing was 8 solar masses of star being ripped apart in a fraction of a second, a detonation so powerful that nearly 1,000 years later, the explosion is still expanding. And the thing it left behind, it breaks physics in ways we're only beginning to understand. For most of human history, the sky was eternal. Stars didn't change. They didn't appear. They certainly didn't explode. Then in July of 1054, Chinese astronomers recorded a guest star in the constellation we now call Taurus. They noted it was visible during the day. They noted it outshone Venus. They noted it took 2 full years to fade from view. Similar records appeared in Japan, possibly in the Middle East. Native American rock art in Arizona may even depict it, a crescent moon beside a bright circle, dated to the same period. Think about that. This explosion was so bright that civilizations across the planet, with no contact between them, all independently said, "Something impossible just happened in the sky." But here's what makes it truly strange. When modern astronomers pointed their telescopes at those exact coordinates, they didn't find empty space. They found something still violently alive, a cloud of debris expanding at 1,500 kilometers per second, and at its heart, an object rotating 30 times every single second. The star didn't just die. It transformed into something we didn't even have words for until 1968. Here's how a star screams itself to death. For millions of years, a massive star burns hydrogen into helium, helium into carbon, carbon into heavier elements, all the way up to iron. Iron is the dead end. Fusing iron doesn't release energy, it absorbs it. So when the core becomes iron, it's like the engine suddenly stops. For 1 terrible second, gravity wins completely. The core collapses at 70,000 kilometers per second, a quarter the speed of light. Picture Earth crushed to the size of a city block. That's roughly the density we're talking about. Protons and electrons are literally squeezed together into neutrons. The collapsing material slams into this new neutron core and bounces. That bounce sends a shockwave outward. The shockwave tears the star apart from the inside. The energy released in 10 seconds exceeds what our sun will produce in its entire 10 billion year lifetime. Wait, let that number land. 10 seconds of dying equals 10 billion years of living. The outer layers of the star are blasted into space at a significant fraction of light speed. This is what created the Crab Nebula, which leads to the part that most people never hear about. The explosion was spectacular, but the corpse is terrifying. At the center of the Crab Nebula sits a neutron star just 20 kilometers across. It contains 1.4 times the mass of our sun. A teaspoon of its material would weigh 6 billion tons on Earth. It spins 30 times per second, fast enough that its equator moves at a significant fraction of light speed. And with each rotation, it sweeps beams of radiation across the cosmos like a lighthouse from hell. We call it a pulsar. The Crab pulsar was the first one ever directly linked to a supernova. It emits radiation across the entire electromagnetic spectrum: radio, visible light, X-rays, gamma rays. It's so energetic that it powers the entire nebula around it, even now, 970 years later. The nebula glows because this dead star refuses to fade quietly. Here's what breaks our assumptions. This object is so dense that the physics at its core may not follow the rules we understand. The neutrons might be dissolving into a soup of quarks. We don't know. We can't recreate these conditions. We can only watch. So the real question is, does this change what we think is possible? Right now, the Crab Nebula is one of the most studied objects in the entire sky. The James Webb Space Telescope captured new images in 2023, revealing structures we'd never seen before, intricate filaments of dust and gas that challenge our models of how supernova remnants evolve. Researchers are using these observations to test fundamental physics. How do particles accelerate to nearly light speed? What happens to matter at nuclear densities? Is there exotic matter at the pulsar's core? Teams at observatories across the world are tracking the nebula's expansion with milliarcsecond precision, essentially watching the explosion unfold in slow motion across human timescales. The crab isn't just history, it's a laboratory, and the scientists studying it know something most people don't. Supernovae like this one seeded the universe with the heavy elements that make life possible. The calcium in your bones, the iron in your blood, forged in explosions exactly like this. We are, quite literally, studying our own origin story. Almost 1,000 years ago, people across Earth looked up and saw a star die in broad daylight. They didn't know what it meant. They couldn't have imagined that the light came from 6,000 light years away, that it signaled the birth of an object denser than anything they could conceive, that the debris would still be racing outward today. Now we know. And somehow, knowing makes it more beautiful, not less. The universe doesn't just destroy, it transforms. Here's my question for you. If a supernova went off close enough to see in daylight during your lifetime, would you want to know in advance? Follow for more, we post every week.